Let's say I want to make how urgent I find it. Especially they're like different. Or the one that you talked about. Or the worst. You might take those first, but maybe it's not. I think when I'm going through your eighth grade, it could be it's never answered my question. So I'm doing one study.
I mean, it is relatively. All right. If you guys haven't had a chance to sign up for AP Classroom, I'll make sure to give you enough time at the end of class where you can do it. It should only take less than 5 minutes to do it. I think a lot of you guys have already done it. I sent out the text remind yesterday. Basically, you just go into apcentral.collegeboard.org. Many of you guys have already taken AP exams before, so you already have a College Board account. And then once you go in, you can use this join code to join AP class. Well, it's twofold. There's two purposes here. One is by doing this, you are doing AP exam registration for BC Calculus. So it's a one-time thing. Once you do it, then you're set. But there's like a deadline of November where if you don't sign up by November, there's like a $40 late fee. But I'm hoping that I can check everyone off so that we can I can make sure that everyone is taken care of and that we don't have to worry about it, because once time passes, we're going to forget about it, and that deadline is going to creep up before we know it. And then, so that's one thing. The second is that you can be able to have access to all the resources that AP Classroom has. So once you're in, you can start exploring. I may ask one of you guys to kind of show me the student view that you see on your end, because I can see what's on my teacher end, but I can't see what you guys see. I'm not going to do anything anything that's grade related. I'm not going to do anything that's grade related for AP Classroom as of now. That I can think of right now. So I'm going to release everything that AP Classroom has to offer for Unit 1 and 2. I think I start doing that. So you can see all these assignments, and these assignments have no deadline. It's just for you to explore. So there's videos that teachers who connected to College Board have made, and you also are going to see notes and guide, going through certain topics, progress, like quizzes that you can take. So I think these are all really, really good resources. I'm not going to do, I know some teachers, they do grading through AP Classroom or give assignments through AP Classroom, but I'm not going to do that. But I do want to give you that resource so that I'll release everything to you so that you can explore. I think all the quizzes that you take, they will give you a grade, but they also give you, they'll score you, but then they also tell you, show you the solution. So you kind of go back and hopefully you guys are able to check. But I may ask one of you guys to show me what you see on your end, so I can kind of have an idea how my end connects with yours. But yeah. Okay, so hopefully we can all get this done within the next few days if we haven't already done so. Any questions here with AP Classroom or with signing up? Okay. Quick recap of our calendar. So we're going to finish up on our 2.1, 2.5 quiz review. Tomorrow, we're going to start our next units. Wednesday, we'll do 3.2 input differentiation. And tomorrow and Wednesday, there's going to be map testing going on. So I think advisement is going to be extended and all the periods will be cut short by a little bit. So that's why I wanted to move the quiz to Thursday. So With the chain rules tomorrow, it's just differentiation. Obviously, these are not going to be on the quiz. But they are natural progression of what we've done so far. So, in a sense, we're kind of reviewing, as we're doing this material. And then, quiz on Thursday. I will have a morning quiz review. Wednesday, it's Thursday morning. Thursday is your quiz, but Thursday morning, I'm giving a test review, morning review to, my AV students. So I'm not gonna have an additional review for you guys for this morning review. But if you have any questions, if you want me to go over, any specific topics, I'm happy to do that. Okay, so 7:15 a.m. Wednesday. I will also send out a Teams link. In case you want to join the quiz review through Teams, and I'll record it as well. So I'll send out that link Wednesday morning. So if you want to join the help session through Teams, you can do that. Okay, any questions about that? Okay, let's go to our quiz review. Hopefully we got through first two pages. If we haven't, then continue working through. So go ahead and start on page 3. I'm hoping we can get through pages 3 and 4 today. And I'll also, put the solutions up as you guys are working through. And then the key is also attached in your packet. So you should be able to also kind of monitor your own progress. Okay, so I'll be back in a few minutes. I'll start going over some problems on page 3, but I want you guys to go ahead and start that first.
So that he can start looking so enough. So it's just an essay to see what just happened. And they don't focus on this. That's why that's all already lazy. I'm not lying. I'm just I think it's cold. I was in here on fire.
What?
The other function.
Oh, it was the worst.
Okay, yeah, house Q three. That was okay. I think we just check. What's the? Oh, that's not nice.
They should probably get for the fact that you're like figuring it out.
Yeah.
What they're doing here. It should be good. What? Yeah, things are on like the becoming less easier. If you're also, what's like, I think easier for. It might be like already yeah. But if it was an entire week, it could be 7 minutes to like maybe over like 30 minutes a day. 30 minutes a day. So if you like, but now it's good. Goodbye. Yeah. I was just gonna do it. Like, because I'm getting pressed. Like, I work on AI. I do, you can do it with something. Yeah. Like, today, because today I think I was on being an investment company, and they're giving me access to quantum data. It's like real like financial stuff. They need to do like an FBI background of my fingerprints and making sure I'm like a super criminal. It's actually like lengths long before like 8 pages long. Every single answer is every step random to like oh are you kidding me? Oh, and it's you know, it's you know, that's I guess like technically and then you know, like and then your words. Yeah, that's I'm gonna do it. I want to get okay. That's 100. Look at it. Yes. Oh, you're great. I forgot that you canceled that stuff. I remember this in all these. I don't know, like they say you to do that right idea. I mean, this is for 1 AM. Just watch it like plug in something, right? I'm supposed to use it. Yeah, like that was supposed to be. You say what am I expecting?
That's what you did.
Oh, it's like this? Hold on. I hear this. A plus 3x plus 6. Oh, yeah, it is like, yeah, and then it's
Crazy.
oh, and then you plug in 0 actually into here and then it's subtract them. Okay, that's not that bad. Solve one for it. Just the direct substitution. There, it means it's the performance. You're doing something. Wait. These all cancel out, it's like -2, but I'll do 2x with those. Right, so since h is equal to 0, there's good for that.
So that was for the space. Or like we went to Dallas. And then I don't know, every I don't know, the side of it. There's like 1 minute wait for it. Crazy. And then like, yes. You know, it's funny. I didn't anything.
You just forgot what you're doing.
What?
I'm so, I don't even know what I'm doing.
Okay.
This is 40 years ago. Yes, that's what it's. That's still in college.
I'm still a must.
Yeah, it's fine. It's just. Luke's pretty good at that. What do you think? I do not have to use that. My heads are sure.
Yeah, last year when we were playing solitaire that one time. Yes.
Oh, that was so annoying.
There's no way. This so.
So, that was good.
So.
That's pretty good.
I must not understand.
It actually hurt.
We're at the same thing.
But like if you race, then.
I think that I don't see what's. I really. What?
He sat down and he just looks so special. So quiet.
Yo, I joined the.
Yeah,
Yeah, people joined, right? They can be that.
He's another.
They try to do Star Trek video.
No, I guess like this, I just don't think I like it. I can like.
Well, like social finance, social finance.
Are you sure?
I'm okay.
I didn't feel that.
I don't think they would like. They have like.
Show that you're intent. Get back to the.
Giving back.
Yeah, giving back.
No. I don't think it's a good.
I think it is.
No.
Wait, what'd you get? I hate how food is good.
Track it off there. Track it off
Where did I get it?
That's from you voting. Thank you. I get to see you talk to me. Because I made it. I'm not. I give me that song. I want to see. You have a ton of those. Can I see the other?
Oh, oh my God, that's so many for the first one. Just like, this looks like a kid bag. Like, I don't know.
I survived too.
Okay, and then you fly. We like 10 days.
Man, this is, I don't. I
But that was like, it was also really easy to see.
And also, it's like.
Yeah, so yeah, question.
And what, I see.
It's like, I would be good on which kind of line.
Yeah, I was thinking of that. I did that.
I don't think I ever. That was like.
I actually try and learn.
Yeah, there is a difference.
I'm not missing bio.
Like, off of my eyelash.
Yes. Yeah. It's like, bro. Yeah, you know what? I don't feel there. Like, sure, let me drop everything to me. Yeah, I know. Yeah, imagine if you had anything, you could just pull. Yeah, I know. Sometimes.
Because like every time I think about it, it's like, I don't know if you're serious. It's like, wait, what are you talking about? Nothing more we can do about it. It's just like, you're doing.
Okay, let me highlight a few, let me go through each of the problems here, make sure that you guys don't have any questions. So this is 16 on page 3. It says use the table below to estimate the value of d prime of 120. We know d prime is going to be the rate of change at a specific point. Now, we don't have a derivative function that can tell us the exact rate of change at 120. But what we can do is we can use a limited resource that we have and make the best approximation that we can make. And the closer that we are to our target, the better our approximation is. So the closest thing that we can find are 60 and 80. So we're going to take those two word pairs and do change of d, or change in feet over the change in time. And so that tells us that at least to the best of our ability, we can approximate the rate of change of at 120 to be 3.3 feet per second. That this object is moving at this rate of change at this moment in time. Okay, so d prime 120 means the approximated rate of change of the particle at 120 seconds is 3.3 feet per second. Number 17 is the function differentiable at x equals 2. So differentiable means do the two graphs or is the graph going to have one singular slope at x equals 2? So what we can do is basically we're just going to be testing each piecewise function's derivative and see if their slopes are matching. So basically, your functions, your limit will exist if the one side limits are in agreement. But we can also say that our function is differentiable if the one-sided limit of the derivative is equal. So if I think about a graph, x approaches c, if the slope as it approaches c is 1/2 from the left, or if the slope as x approaches c from the left is 1/2, and the slope as it approaches c from the right is also 1/2, we know that these two behaviors are going to link up in a way where it's going to be a smooth transition. There's not going to be a slope 1/2 turn into a slope of 1. It's going to be a slope 1/2, and then gradually 1/2 links up with that slope, and then everything ends up being smooth. So I'm just finding the derivative of both my piecewise functions. I'm finding each of the one-sided limit of this derivative by doing direct substitution, and I see that they're both giving me a slope of -9. So it's approaching a slope of -9, and it's also approaching a slope of -9 from both sides. So we know that this graph is going to have a smooth transition at 2. So yes, my and is continuous at 2. So differentiable means that it's got to be they must have a same slope at those 2 points, but we also want to double check that it's actually continuous as well, because if it's differentiable, I mean, if they, we got a slope of 1/2 from this side and a slope of 1/2 from the other side as well. Sorry. All right. And they may have the same slope there, but if they're not connected, then we can't call them differentiable. So we also needed to make sure that at 2, the one side limits are also approaching the same y value, and they are. So they're approaching the same y value at 2, and they're also approaching the same slope at 2. That links up very well. We know that our function is differentiable. Okay, 18, this type of problem is very important for us to be able to do because this shows up a lot of AP exams. And it says, what values of a and b would make the function differentiable at x equals 4? So we want the two branches to connect in a way where they not only share the same slope, they also share the same point. And that allows us to create systems of equations that will give us the ability to solve for a and for b. So the strategy for these problems, you're going to be setting both your expressions equal to each other. And then you're also going to set each of their derivatives equal to each other, because we know that at 4, they must share the same y value, and also at 4, they must share the same derivative or same slope. If we can set those two equations up, that will allow us to have enough information to solve for a and then to solve for b. And it doesn't matter which one you solve for first. You just want to kind of see what the problem gives you and go as and kind of take the path of least resistance. So I can set these expressions equal to each other. So I'm going to, I set those two equations equal to each other. I replace all the x value at 4, or I replace all the x's with 4. And that will allow me to create an equation for me to work with. I'm not able to solve for a or b at this moment, but at least I have something that I can come back to. And then the second part is I know they must share the same slope because that's what we want, right? Differentiable at x equals 4. So I'm going to find each of these terms derivative. Make sure that you treat a and b like constants or coefficient or unknown constants. So if I want to find the derivative of a times square root of x, the same thing as 1/2. X to the 1/2 times a. I can go through power rule. 1/2 a x to the negative 1/2, and then bx squared becomes 2bx. -1 goes away to 0. And the derivative of 16 over x, I got to bring that x up to the top and get it ready for power rule. So that becomes -16x to -2, and bx becomes just b, right? Imagine 3x, right? 3x becomes 3, and bx will just become b. So once I find their derivatives, I set them equal to each other. I can replace all the x's with 4. That's what I did here. Replace all the x's with 4, replace all the x's with 4, set them equal to each other. And then now once I clean that up, I have two equations that I can work with here. I have a is equal to, well, first I have a over 4 plus 8b equals -1 plus b. I just wanted to work, do substitution without dealing with that fraction. So I distributed a 4 through, and I cleaned it up as much as I can. So I have one equation that's easy to work with, another equation that also seems a little cleaner, and then I'm just going to do direct substitution or substitution, so I can solve for one unknown constant at a time. I got b equals -13 over 44, and I got a equals 47 over 11. I want to make sure that everyone is comfortable with the setup, right? So 18, this is the hardest part about 18 is just knowing what to do, right? If you know what to do, then the rest of it is just, going through the steps. Right? So are we okay with 18? Because you'll see a problem like that on the quiz.
So we just ignore the second equation of the original function, or?
Oh, this one here?
Yeah.
I did not, well, I didn't show the cleaned up version of this. That is actually 16x to the -1 plus bx. I didn't show that cleanup step, but once I have that equation, I did. I set the equations equal to each other, but I went ahead and I just replaced all the x's with 4, and then I found the derivative from here. The derivative of 16x to -1 is -16x to -2 right here, and then bx becomes b.
Oh, so you said the original function is equal, that you get one of the variables.
That's right. And then I set the other, the derivatives equal to each other to help me get the other operator. But you're gonna need both equations, because both equations, if you have two missing values or two unknown constants, you need two separate equations to help you solve for one and then solve for the other.
Yeah.
Okay. But make sure that you go through this from scratch so you can make sure that, because it's one thing to look at the solution and understand what's going on, but until you try it from scratch, that's a different experience, right? So. Okay, are we good with 18? Okay, so 19, it says each limit represents the instantaneous rate of change of a function. Identify the original function and the x value of the instantaneous rate of change. So we talked about this, how we're using the limit definition not to find the limit, but really to see if students, if we can decipher what that notation is telling us. So this 19 is in the form of the alternate definition of a derivative. We know that this is asking for the derivative of this function at x equals 4. So I know that this is referring to x squared minus 3x. It's asking for the derivative at 4. And if I were to find that derivative, I'm just using this to help me get what information is given me. I know I'm trying to find f prime of 4. I can then revert to a much simpler method, f prime of 4. I can use going through power rule, and then I can get up to 5. So as long as I know what 19 is asking for, I'm just going to go through a much more efficient process to get to the answer. But the important thing of the limit definition is understanding what it's asking for, and then being able to pull what function that is referring to. So number 20 looks a little strange because it has the general definition of a limit built into that problem. Kind of it's filled out halfway, and it's asking for the slope at a point because all the x's got replaced with 5. So we can kind of decipher that this is really coming from 9x minus 10x squared. So we can understand that it's asking for this function's derivative at x equals 5. If I know what it's asking for, then it becomes a really simple problem. Imagine here's my function, here's my derivative, evaluate my derivative at 5, and n equals -91. So we're not really doing the steps within the definition, because we have a much more efficient process. But as long as we know what this is referring to and is what it's asking for, it's we can just take that and run with it from a power rule standpoint. Okay, page 21, page 4, I think this is a lot more straightforward. You know, you're gonna find the derivative using, in this case, either product or quotient rule, replacing all the x's with whatever x value that they're asking you to use. And then using substitution from your table of values to get it down to a numeric value. So product rule for A, quotient rule for B, and then again, product rule for C. Okay, 22. What x value does the function have a horizontal tangent? So horizontal tangent means slope 0. So it's basically asking, you know, this graph looks like this. Can you tell me all the places where there's a slope 0? So we can simply take our derivative, set equal to 0, and then when we solve for x, we can find all the locations where that slope 0 occurs, right? Maybe it's 1, maybe it's 2, maybe it's equal, but want to make sure that we know what it's asking for and know how to set it up to solve for what you're looking for. Okay. So find f prime, set f prime equal to 0, solve for x. It's just asking for the x values. If it's asking for the full ordered pairs, then you will take these x values, insert back into the original function, and find those y values. But here's only asking for the x values of those slope 0 behavior. Okay, 23 is just making sure that we know our derivative rules for trig, and also our trig unit circle values. Right. So I want to point something out here is that if this was an AP exam problem for response, you cannot leave your answer like this. This is not correct. Okay. So I said before that you can leave your answer unsimplified, but this is not simplified enough. You have to get down to your numeric representation of that trig ratio. So you can't just say, oh, cosine pi over 3, leave it like that. You have to tell me it's 1/2. You have to tell me this is negative root 3 over 2. Okay. Now you don't have to combine like terms. You can leave your answer in like this form, right? So this is fine, but I cannot have a unfinished trig expression. Got to make my way down to a ratio. Okay, so we know that S prime represents rate of change. So if S of X is the number of students in class, then we know S prime is going to be the rate at which the number of students is either increasing or decreasing, depending if your S prime is positive or negative. And 25 is just asking for average rate of change. So there's no derivative going on here. You're just doing change in y over change in x, and then using your graph to help you find those y values. So this is a composite function here, which means I need to find g of 4 before I can find f of that value. So g of 4 is 1, then I can do f of 1, f of 1. Now look at my f graph, 1 is 0.5. Right. A and B, you're just doing slope and pulling your information from your graph. Okay, any questions? Okay, let me know if you have any questions. And then I can